Hello everybody and welcome to Saturday Morning Coding. Today we are gonna first of all we are gonna make this this function more flexible, and yeah, we will have a radius, so we can see how the different radius is applied to different how the radius affects the blur. The box blur is the most basic type of blur anyway. So we are taking a pixel and all the neighbors up to certain radius, and then the value of the pixel is that the average of himself and all the neighbors that we are taking. Yeah, so I'm looking for an image. So yeah, image, and now we can say radius here, which is an integer, and then here instead we do minus radius x plus radius plus 1, and same here, x minus radius to y plus radius plus 1. So now I'm gonna find an image to test this, smaller than the other two because this is obviously very slow as it is now. So we're gonna see how the blur affects this is 800 by 800, so that should be okay. So I'm gonna save this image. Image processing test. Okay, so yeah, this is our image. It's 800 by 800, and we are gonna figure out how we are gonna see how the blur affects this image. Obviously, we are only working with grayscale image, so the first step will be to transform it to grayscale. This doesn't work anymore. So first we save it. So it's called puffin.jpg, and we save it in the test folder instead of the out folder as puffin black and white. So we have it already for the blur in black and white. So here is the original image, and here is our transformation to black and white. So now we are gonna test how does it look when we apply a box blur with different radiuses, so we can see how the radiuses affect the blur. So now that we have the image transformed to black and white with our own routine, we can do for radius in range 2 to 15, we open the image. We need to work with an image, with the same image all the time. So image is now we don't need to import this anymore. Box blur gray with this image and the radius, and then we save the image in out. I'm gonna call this puffin blur, and then we can use an F string here for ease. So is it so? Will this work? So yeah, now we are gonna have from a radius 1 to a radius 15 the image blurred. So we can see how this radius affects the box blur, which, as I said, is quite quite a basic way of doing blur. There's better ways to do blur, but as a starter, this is good. And I'm gonna print here a message so we can see print blurring image with radius. Okay, so now we run it. This is gonna take a little bit, but let's see. It's very likely that the bigger the radius, the bigger the longer the image takes, because every pixel needs to take into account more pixels. So in the meantime, we can start seeing how the images that are out, if we can actually see them. How do those look? So we are in this. So yeah, the problem for this is that it's slow. So there's always ways with pixel-wise image processing tends to be quite slow, especially in a language like Python. We could be doing this in C++ or in Rust or in some compiled language, probably will be much faster, but yeah, let's see. In the meantime, I'm gonna explain as well the idea. I'm gonna switch to the whiteboard and explain the idea. Explain again what we are doing. So, oops, I forgot to change this this text. Yes. So now let's go to the iPad. Yeah, so essentially what we are doing is that, as I was explaining the other day, so this would be with radius 1, and by radius we mean this. So this is the pixel that we are operating in. These are the relative weights, and this means that we calculate that we actually calculate the average, because it could be a weighted average, and some of the filters that we are gonna be eventually saying they have the average, weighted average, like Gaussian blur or some other types of blur. But the basic idea is this. So for a radius of 2, this would be and this is the pixel that is going to be on operation, and this is the radius. So there's 1, 2, 1, 2. I know that it's a little bit not totally proper to call it radius, because it's not a radius, and because this distance is bigger, the diagonal distance. Yeah, we can't call it. Yeah, we can. I mean, we call it radius anyway. Yeah. So this is the idea, and obviously because it's an average, this would be 1 times 25. I mean, y times 1 divided by 25, because there's 25 pixels when you get the radius 2, and so on up to the radius, up to any radius basically that you want. Obviously, as I was saying, the bigger the radius, the slower it becomes because of the nature of the algorithm. Basically, the algorithm does for every pixel, um, for every pixel in neighborhood. So this means that the bigger the neighborhood, the more operations the algorithm needs to do for every pixel. So yeah, we have processed up to 7, and I can show you actually if you see the difference. I mean, the difference is quite noticeable. Yeah, so let's change back to this. Now you are seeing with radius 1. I don't know how well you can see them, but yeah. But yeah, this is radius 1. You can see it keeps the sharpness. This is radius 2. And radius 2. You can see that it's already started to be blurred. It's hard to make a comparison like this, but yeah. This is blur 2, and this is blur 1. And this is blur 8 with the current method. So you can see that actually the image gets blurry, and you may think, what is the purpose of making an image blurry? Many algorithms use this type of blur, maybe not exactly the box blur, but something like Gaussian blur or something, because it reduces the amount of detail of the image, which is something that is desirable in some ways. So yeah, so by applying this algorithm, which is basically averaging every pixel with the neighbor, you get a blur. Like, this is the most basic type of blur. And obviously, this is a little bit more tricky in color images. That's why we are sticking to black and white yet, because yeah, color is a way more difficult thing. But yeah, so you see from blur 1 to blur 8, there's a big difference already. And yeah, we are processing the rest of the images until radius 15. Maybe I stop it at radius 10, because otherwise we are gonna be waiting for way too long. But yeah, so yeah, and as I explained, I mean, there is the yeah, I'm gonna go through the code one less time, but yeah, so this basically checks if the image is grayscale, it loads the pixels, and then, I mean, this is not even the fastest way to do this inside this library, but yeah, this creates a new image for the blur, because this is the tricky thing as well, that you cannot do it in place, because the moment you modify the pixel, one pixel, you can that pixel is gonna be used as the neighbor of others. So it's quite tricky to do this in place, memory wise. I mean, probably it's possible if you are calculating the values in parallel and then substituting them after you have calculated all the values. But yeah. Okay, so we are in 10 now. And when the image 10 is done, I'm gonna show you the image 10, and we can go to a different type of operation. We are gonna do the thresholding, which is another of the building blocks of the image processing, and the thresholding is fairly easy to understand, but yeah, we are building these building blocks one by one, and then we can combine them. Yeah. We can start. There's many different ways of, I mean, you will see also that ways of being clever with the threshold, but so far it's gonna be the basic threshold based on a value. So the threshold can be done in place, which is good. Which is good. the threshold, we receive an image, a value which is an integer, and we return no return, and then we basically do yeah, I'm gonna explain the operation, which is because it's easy. Yeah, I'm gonna show you now the difference between radius 1 and radius 10. So you can see that it effectively blurs the image, and the bigger the radius, the more blurred it is. So this would be 5, 1, 5, radius 10. So this is the box blur, which is the most basic type of blur. So now, what is thresholding? Well, I don't even need to go to the iPad to explain it. Like, it's basically you have a value, and everything. It makes the image binary, so it stops being grayscale, and there's only the minimum possible value and the maximum possible value on the image. And this value is the limit. Everything above it becomes maximum value, and everything below it becomes minimum value, unless it's inverse. That's why I added this inverse value here. In that case, you switch, and the values above will become the minimum value, and the values below will become the maximum value. So yeah, this is easy. I'm gonna just copy the checks from here, and now copy the if px of xy is bigger or equal than value, then do this, else do the other thing, and then we need to check if inverse else pass. So if it's bigger, then it becomes the maximum value, which is no, this is if it's the, and if it's inverse and it's above, it becomes the minimum value, and then this goes the other way around. And this should be a much faster operation than the one with the yeah, this thresholding operation. So now, for example, let's try from SPI dot threshold import threshold. So we do threshold over this image, and we put the value at 128, which is the middle. And then inverse is false. Actually, what I'm gonna do is inverse so if you don't say anything, if you don't specify, the value takes a default of false for the inverse, so it's not inverse by default. And yeah, this is the result. So you see that there's only 2 values for the image. This is also a very important step on many image processing algorithms to detect borders or detect shapes or this or the other thing. And if I type inverse true here, then we need to have the inverse image. So this is the original, and this is the inverse. As you can see, it's working. We can try with different values. For example, if I type here that a lower value like 64, for example, you can see the difference. This is 128 and this is 64. And this points towards another artifact that is used quite commonly in the image processing, which is the histogram. The histogram is essentially a count for every possible value of gray in this case, because we are doing grayscale image. For every possible value of gray, how many pixels there are in the image, and this is used to do clever thresholding, as we are gonna see. So now we are gonna calculate the histogram. So now we can have a new package histogram. For example, in a color image that is in the RGB color space, you would have 3 histograms, one for red, one for green, and one for blue. So it would be like a 3-channel histogram. But we are working with grayscale images, so we are working only with black and white images, so we basically can copy all this. And then our histogram will be an, we can start histogram, no, histogram, and this returns a list. Histogram equals 0 for x in range 256. So it started at 0 for every possible value, and then we do histogram of px of x, y plus plus or plus equals 1. And then we return the histogram. We don't need the x there. And then now, for example, we want to get the histogram of our histogram equals get histogram of image, and I'm gonna just do a, so we can debug and see the values that are coming from the image. So now we can see for every value the amount of pixels that are in the image. As you can see, that there is interesting possibilities with this. You can calculate the real quartile, or you can do statistics with this, considering this as a discrete function, and you can calculate the statistics over the image on this, and then apply other effects based on calculations on the histogram. That's why this is very important. You can consider this as a function. It's a discrete function, not a continuous function, but you can apply statistics to this. Like we could say, for example, how what is the value that contains half of the pixels or more, and then apply the threshold based on that value. And that's something that we can do here. Get I'm gonna call it get 50 value. So this function will calculate the value that contains more than half, the first value that accumulates more than half of the pixels. So this is integer division because it doesn't make any sense to calculate for half a pixel. So for E in range 256, count equals 0. For E in range 256, count plus equals histogram of E. And then if count is bigger or equal than half pixels, then return, I'm gonna call this current value, return current value. This would always return something, but just in case, for completeness, we can say just return -1 here, which is an invalid value, but it doesn't matter. So now, something that I'm gonna call this maybe half better. So now something that we can do with this, combining both things, is we get the histogram and we calculate the average value. I mean, not the average, the half value. Get histogram, get half value, and then we do get half value of histogram, and then we print the half value. To 25. If now I apply a threshold for that value, and I calculate the histogram again, the histogram should have half pixels on the top, on the values, on the minimum value, and half pixels on the maximum value. Well, one up or one down, because the value, I mean, more or less, it's the first value that contains half of the pixels or more. So these two numbers do not necessarily need to be the same. But if I save the image now, in threshold half .jpg. This is the image when half of the pixels are translated to more or less half and half to maximum and minimum values. This is not really that useful. For example, for contrast increase, which is something that we are going to start to do soon, in black and white images, contrast increase many times, at least part of the methods consist on cleverly finding a threshold, cleverly finding a value on the histogram, and then apply, expand the difference between those, making the values to the less than the clever value. Those become darker or lighter, and the other ones darker, and so on. And that's how you increase contrast. So there's a whole bunch of methods that with the histogram allow us to operate to a bunch of contrast enhancement methods that use the histogram as a way to do uh, stuff on the image, and we are gonna get there soon. But yeah, this is all I wanted to do for today. It's probably a little bit shorter of a chapter, but yeah, in next one we are gonna be um, starting with contrast enhancement. You can see here all the images that we have produced today. And yeah, any questions or anything, just drop them to me in the chat or something. Um, yeah, and that's it. Thank you for passing by, and this will be on YouTube. You can follow me on the on my Twitter, on my yeah, on my Instagram. I was gonna say I have Instagram, but it's irrelevant. So you can follow me on Twitter, and yeah, next chapter will be contrast enhancement. So stay tuned for that, because now we have the tools. We have the blur, we have the threshold, and we have the histogram. So we can start exploring contrast enhancement. Yeah, that's it. Thank you for passing by, and see you next weekend with contrast enhancement. Bye.